Hey guys, thanks for coming down today. Just getting set up here. Hope you're having a great time. Cool. Okay, so my name is Benedict Chan. I am the CTO at BitGo. So BitGo actually we started out in 2013 with the first multi-sig web wallet. At the time we were known for security, and our first users were enterprise users. Soon we became the wallet behind many exchanges like Bitstamp, Coin Payments, even Upbit is using our wallet at the back end, and Chicago Mercantile Exchange. So slightly more than a year ago, we only had just Bitcoin support, and our transactions were involved with about 12% of the Bitcoin network. But now this month, we are transacting in excess of about $10 billion a month over our new multi-currency platform, and it's all on-chain. So here are some of the companies that use our wallets. So today I want to discuss a few things. First, I'd like to share a little about wallets, where we see the place of wallets in the ecosystem and how BitGo built our scalable multi-currency wallet platform. And then we'll talk about some of the improvements and innovations that we've seen in the past year, state of the wallet industry, some challenges, and how we see the wallet space growing. So starting with the most basic diagram, wallets are one of the most basic applications on any blockchain platform. If a blockchain is a distributed database, then the wallets are the first application on top of the database, and they serve to monitor the transactions, combine key management, and implement an interface for users to interact with the blockchain. So every blockchain needs wallets, and in many cases you can look at, when you look at success of a blockchain, you can look at not just the theoretical potential in terms of TPS, but adoption. And I think adoption is driven a lot by scalability, number of developers, wallets, and exchange integrations. So at BitGo, we started building our multi-currency wallet platform around the end of 2016. At the time, it was not really an easy decision because many of us were actually still big believers in Bitcoin, and some of you there will remember that the price of Ethereum was just $750, and not $750, just $7.50. Although now it's quite clear that we currently live in a multi-currency world. We have over 2,000 currencies on CoinMarketCap, and as infrastructure providers, our mission is to make digital currency accessible to the world. So we wanted to create an interface that would support every blockchain type, abstracting away transactional differences such as unspends and nonces. And it was, of course, it had to be safe. We have our roots in security, and it's very important. So the blockchain is, very powerful, but it's also immutable. So once money is stolen, then it's irrevocably lost. And we don't want to lose trust of our users. Lastly, we have to take complexity out of the picture for the user. That means that the less work that our users have to do to deal with forks, airdrops, and tokens, and so on, the better. And of course, we want to be able to scale as a blockchain succeeds, right? So here's an early slide of the differences between Bitcoin and Ethereum. Many of you know that they are fundamentally quite different. Bitcoin is unspends-based, and Ethereum uses the concept of accounts. And there's actually very many different blockchains today, and each of them have slightly different implementations, different signing algorithms, transaction format, consensus model, and so on. But the user really doesn't care about this. So our job is to provide a consistent experience for the user. So this is actually some snaps of the SDK that we launched. It's available today. So any users can initialize it for any coin in an identical way except for the ticker code that you use. So you can just put BTC, but you can substitute that for ETH or even any ERC20 tokens that we support, Ripple, Bitcoin Cash, Zcash, and so on. So there's actually several interfaces and exchanges out there that say they can support multiple currencies. But to my knowledge, this is one of the few SDKs that works across all these coins in a non-custodial way, meaning that you control the keys, and we power many of those exchanges. So if you want to build an experience that heavily deals in security and storage and transactions of multiple coins, then this is one of the building blocks that you can use. So creating a wallet is really easy. You just set a label and a passphrase, and then it will create the wallet with the chosen type. And you can create many addresses as needed for the user deposits. You can list the transfers, it's very simple. And the send interface is always the same, doesn't matter which coin you're sending, whether you're sending Bitcoin or Ethereum or Ripples or Zcash. There's always an address and there's always an amount. And this is a very standard type of interface that works across multiple coin types. So here's a screenshot of what it looks like when we implement it on a web client. Everything in the web client is using the same SDK, and this is how it looks like when you implement in one of our customers. I couldn't get into the Upbit UI to take a screenshot because I'm not Korean, but I imagine it looked very similar. So this is going to take a while to explain. Now that some of you have seen what our platform actually does, I'll just share a little technical background on how it works. So we can start by looking at the client. So BitGo's wallet, it allows you to control your own keys, and it's fully multi-sig. So our client needs to be able to handle those sensitive key operations. Customers, they can install this SDK client and interact with it using JavaScript or REST API, and SDK is open source. And all products like the web interface and so on, they utilize the same base SDK. So this is a choice we made for extensive testing and good code reuse. Within the SDK, we utilize industry standard coin-specific libraries such as Bitcoin JSLib, Ethereum JSTX, and other Ripple libs, and we abstract away all the transaction creation so that the user can just call transfer, and our SDK will select the appropriate library using a strategy design pattern. And then the SDK calls the platform, which is behind a set of load balancers and CDNs in order to get the wallet and key information. So on the platform, we have a single coin interface with coin-specific libraries to assist with transaction and wallet handling. The platform creates an unsigned transaction based on unspent and nonce information from the relevant coin cluster, which we'll talk about later. So this is when we're trying to send a transaction. The client SDK, it receives the unsigned transaction, and then it needs to verify the destination amount and address. Because remember, we're trying to be as trustless as possible, and the client is supposed to control the keys. So after it's verified, then it will present it to the user, either in a pop-up or so on. And so the signing has to occur on this client SDK side. And typically, this involves obviously decrypting a key, using a passphrase, and using it to apply the signature. Or this can be done on hardware or software as well. After the first signature on the client has been collected, then the transaction is sent back to the platform API. So the platform service authenticates the user session, and then it checks OTP information and so on, policies and rules. And if needed, it will connect to external services. So it's responsible for storing the wallets associated with users. Our most used model is actually the wallet, which comprises of keys, transfers, rules, and other administrative information. So when the transaction has passed authentication, it's sent to the key service, the key signing service. Behind this key service is actually a hardware security module that is used for signing. The API and HSMs have been built with the same interface, but with coin-specific implementation, so they can sign transactions of any coin type as needed. Often different coins, actually, they have different transaction formats. Like some coins, like Stellar, they use a different elliptic curve. So we need to deal with that. So the HSM is built such that nobody ever has access to the signing key, and the key lives within the hardware machine only, and is tamper-proof. So it's configured such that multiple people need to connect to it to activate it and unlock the signing keys. Only then can it co-sign transactions per rules and policy. Then for each coin, we have a separate indexing cluster here. Indexes are responsible for monitoring every block as it comes in and then searching for matches on all the wallets and addresses that we host. It would not be scalable to look up address balances on the fly directly from the nodes because we actually have many large exchange customers that have hundreds of millions of addresses. So we can't look up all the balances across that when we want to have a single wallet balance. So we have to build our own database index for this. Within the cluster, these databases, they contain all the blockchain information like transactions, blocks, and unspent information for relevant coins and account nonces in the case of Ethereum. So each cluster is abstracted away by a microservice which has multiple instances behind it. And this design allows us to add additional new blockchains to the platform and scale quite horizontally while limiting the impact of adding a new coin. And when a single coin has an outage, for example, I think about 2 weeks ago, Bitcoin Cash they were conducting a stress test. They were making 15 megabyte blocks. So it causes that particular microservice to have some challenges, but other coins were not impacted on the platform. So to finish up the transaction flow, when a transaction is signed by the HSM, it's sent to the corresponding coin cluster, and the indexing service is responsible for picking up the transaction and from the send queue and making sure that it hits the blockchain. So in practice, sometimes this means sending it out and retrying to different peers more than once, and we use several instances of the indexes and peer-to-peer nodes in each cluster for redundability and scalability. In the case of Ethereum, we actually have more than 6 nodes. So in this diagram, I've only shown the Bitcoin cluster and Ethereum cluster, but we have over 10 of these for many, many multiple blockchains so that we can service all of that. So now you've heard about how the platform works. I'm going to share a little bit about what we've been seeing this year for wallets in store. So the first large improvement on storage and security was that we're very thankful for increased support and availability of security hardware. I think there were some other talks about this. So not only has the cost of producing these HSMs has gone down, it's much cheaper to produce. Secure elements are also available on more devices than ever. Apple iPhone has a secure enclave, and most Intel processors have known have Intel SGX, which is a set of CPU instruction codes that enable BIOS level support. So portions of memory can be dedicated for the key to be stored. So we're seeing many wallet developers start to leverage these features in cryptocurrency wallets today for signing. BitGo has also made many improvements to co-signing logic. So we've been adding policies and moving the logic down into the hardware portion of the co-signer. So in the past, the HSM is only used to sign the transaction, but not as much knowing about what the transaction is about. But now we actually have policies such as time limits, whitelists, and we can do things like velocity limits as well within the hardware security. And hardware enforced logic is going to make this signing a lot more safe. Next, Mfa Improvements U2f. I think this is very important. It's not particularly crypto-specific, but the security industry has been working on combating phishing. So phishing is where sometimes the hackers or scammers send an email and it contains a link to a wrong website. So for example, instead of upbit.com, maybe it's like upbeat.com, and then people don't see the URL properly, and they go in there, the bad website, and put in a bad username and password and second factor, and then they get scammed. So this is one of the largest source of loss, but now browsers actually have support for what is known as U2f. It's a FIDO standard for doing 2FA, and it strengthens the 2FA process because browsers can integrate with these low-cost YubiKey devices, and at the touch of a button, now the device doesn't just send one-time codes, but it can sign what's on the screen. And then the signature contains the domain of the browser website that is requesting the signature. So meaning that we can now detect which domain is the user on, and if it's not upbit.com, then it can be seen. So another thing to note, we believe the wallet industry has much to learn from traditional finance. So there are, and have been for many years, processes and regulations for securing, withdrawing, and transferring assets such as gold and silver. And by now, this is almost like very typical to them. So we've been working with many banks and financial institutions. We've applied controls to our cold storage, like time delays, multiple step approval workflows by different teams. And although we're all from crypto industry here, I think we should learn from relevant lessons in the past with regards to securing assets. So scaling challenges operationally within the technical community, we're trying to solve these as well. So these are important because if we are going to prepare for the next wave of users, we want them to actually be able to use the cryptocurrency and not just buy it. So here are some of the challenges we're seeing today. We've always had to deal with scaling to large numbers of addresses because many exchanges, they are onboarding many millions of users. And we have to store and handle these addresses when forks like Bitcoin Cash or Gold or airdrops happen. Unspent selection is also an ongoing challenge for large-scale wallets. So often these wallets, they may take in thousands of deposits a day and make same number of transactions. So for each transaction, you want to select a minimal number of unspents in order to minimize fees, but you don't want to leave too many small inputs on the wallet. So, and you want to make sure you have enough confirmed unspents to use when you need to send. So we need tools to manage this unspent set, And well, if you want to know more information about this, you can check out our blog, but it's an ongoing challenge. Also, on some account-based chains like Ethereum, sending a transaction with a low gas price can result in subsequent transactions getting delayed. So if you send from the same account, because of the way these nonces work, your transactions need to be processed in order on account-based chains. So this needs to be kept in mind when you're designing wallets to optimize fees with large numbers of transactions. And then the blockchains themselves, they also have scaling challenges as a whole, as a system. So Bitcoin is where we sometimes see a transaction fee market develop. And although we have, as a community, implemented SegWit to alleviate some of the fee pressure and block pressure, it still mounts when space and resources are scarce, as it is in a public resource like a blockchain. So calculating the optimal fee or gas price to pay can really add up when you make lots of transactions a month. So some of our partners and customers, they actually spend 6 figures a month in blockchain fees on some exchanges and payment gateways. So on Ethereum, actually, at the start of this year, we hit another limit, which is the practical speed at which the nodes that can process blocks. And we reached close to the limit, and it takes very powerful machines to keep up. As a result, we face some operational concerns, like nodes are dropping out from the network, synchronization delays, and we've seen other services on the network going down. So when you operate in this type of environment, it's very different from when the network is functioning healthily, because memory pools, they fill up, and people, they want to get into the next block quickly, so they start increasing the gas price very fast. And transactions for normal users, they get very unpredictable. So dealing with these and adding automation around that is part of our job. At the same time, we're working on scaling current blockchain platforms. So as a wallet provider, we are building for the next generation of transaction throughput. So side chains are one of the scaling approaches that we are watching very, very closely. So combined with the two-way pegs, it can be plasma style or OST style. This gives us immediate ability to scale out transactions per second on existing networks like Ethereum. Another approach is to actually go off-chain. So this can be done trustlessly in payment channels like Lightning. So I want to talk a little bit about that. So the Lightning Network, it actually has already exceeded 100 Bitcoins in available capacity, even in its current testing phase. So it's proven to be able to send transactions at several orders of magnitude faster and still trustless manner without requiring to be on-chain. And it's available today, so I encourage you to try it. These off-chain payment networks, they present a new approach and workflow to sending, which is, in my personal belief, real scaling and value, it comes out of improving existing networks and the network effect to make them stronger and more ubiquitous. And at BitGo, we are trying to work on how to upgrade Bitcoin payments into Lightning payments while requiring a minimum amount of user efforts. So as we know, we call this flashovers. So as we know, on-chain transactions on Bitcoin right now, they can be relatively slow to confirm and costly if you're sending a small amount. So the first thing at BitGo that we're doing is we're trying to implement Lightning as part of our existing SDKs, which hundreds of exchanges already use. So those familiar with BitGo can run Lightning just out of the box. But you need to recognize that there's a behavioral change over here. So every time you want to pay somebody with Lightning, you need to get a Lightning invoice. And existing users, they only know about Bitcoin addresses. So at this point, we actually have billions of addresses that BitGo customers have created. So how can we still use these addresses and still take advantage of them? So let's look at how we do it. So in typical fashion today, BitGo is powering these many exchanges. Let's say exchange A is Bitstamp and exchange B is Upbit. And when these exchange customers, they want to send from one exchange to the other, they are using addresses. So customer from A will send 5 to B, and it's at a different exchange. So the challenge here is that when customer is sending 5 to B, they don't know that it can be sent over Lightning. They just know the Bitcoin address. So with flashovers, BitGo can identify the recipient holding this destination address, and that both A and B are also Lightning nodes. So BitGo will give a hint to the recipient, telling them to sign a message with the address and give a Lightning invoice instead. And this is needed because to remain trustless, the recipient has to sign to guarantee to A that they are actually in possession of the recipient address, but instead they want to take receipt of the money using a Lightning channel. and they don't want to just send an on-chain payment. So it will be signed by B, and then BitGo can pass this invoice on to the sender, and in this way we can upgrade and take what would have been an on-chain transaction, bring it off-chain, fully harness the effect of the network effect of both the existing addresses and the Lightning Network, and not needing a new channel to be established. So yeah, moving on, as you've seen at this conference, there's plenty of new blockchains coming out to support high throughput transactions. So we have a team over there to support and integrate them, and we evaluate each candidate to build wallets for. So we look at white paper, research consensus algorithms, cryptographic curve support, throughput, and other key features. And then we check the APIs, SDKs, and interesting library programming languages, if they've been updated recently or are not maintained at all. So we check things like, the Reddit channel, Slack, and other forums, so that we can get an idea about how strong is the development community. And most importantly, very importantly, we really care about our customers, so we look at who is asking for the new blockchain support, what the market cap and volume traded is, and this determines if the coin actually has adoption, which is what we're really big on. So at the moment, the wallet consumer and even enterprise consumer space is undergoing development in two separate areas: ease of use when onboarding the customer, and support for decentralized security with private keys held by users. So on one side, we have Upbit and many exchanges trying to bring in new customers and those that are less sophisticated. So this is a must-have for the industry to keep growing, of course. We want to bring in new people into the space, right? So the easiest way to do this is to take the key material and the challenges of holding that out of the picture and do a hosted wallet or custodianship. In fact, BitGo is doing custodianship as well. We recently just got approved in the US to be a crypto custodian. So, and people, some people enjoy the safe feeling of not having to store their own keys. So we're taking a compromise here, decentralization versus user experience. I think when you think about this, not all centralization is bad. Not everyone wants to be their own bank. Some people like others to keep the keys, but it's very important that we give people the option to keep their keys. And the ability to do so by any power user to control their own money is a huge feature that I really enjoy. So I think that in time, it may be possible for users to have devices that are powerful and safe enough for user interfaces to be optimized enough that there will be key operations underneath and security on the edge of every transaction, but we'll have to see. Because to the common user, I think that decentralization is not always tangible. So for instance, it's taken something like more than 10 plus years for encrypted chat to become commonplace. In the old days, everybody was using just ICQ, SMS, and so on. But today, finally, we have WhatsApp, we have Telegram, and Signal. And these are all great apps that have good user experience, but they're actually encrypted behind. And the complexity doesn't go down to the user. It took a long time to get there. So there's also a few solutions to this. So we can do things like we can get users to print out a backup of their key, give a backup key to somebody else. Some blockchains, I think like EOS, for example, they have a kind of like a backup restore feature when you lose your account, which is safe or not safe, depending on how you look at it. But loss of the devices and key is just one of the things, because these keys are all online. And so if the machine holding the keys is hacked or attacked, then you could lose your money. So as we discussed, we saw a lot of investment going into security and creating trust in the space, and treating digital assets like traditional hard assets, so that a lot of the finance institutions can come in and reach the main audience. But at the same time, we have almost on a separate track, we're building more interesting dApps in development, and these are the killer apps of blockchain that the industry is hoping for, rich applications that take it way above money transfer. The challenge is that we're performing many, either the wallets are performing a lot of security checks today or almost none at all with dealing with dApps, such as, these DEXs or CryptoKitty type dApps. And offline vaults for such transactions, they hardly exist. So many wallet providers, they have difficulty supporting both of these types of transactions, because with the rich experiences, we can't be aware of how every dApp works. So for example, in a decentralized exchange, a transaction needs to be made to lock up the funds for the user before trading, and then after this, the transactions need to be made to settle the trade again. So these transactions are not very simple wallet transfer types. So usual rules for them, securing them, they don't always apply. And often the user is going to be requiring to make some advanced operations themselves. So we actually have a following user behavior that is as a result, which is that either the user is probably going to have a large place to store most of their coins, and then they have a small wallet to interact with the dApps. And in some ways, it's very similar to the real world, where I have in my pocket a very small wallet, but I also have a large store at home or in the bank, and I'm okay to wait for a large withdrawal. But when you take a look at other interesting use cases for blockchain, like proof of stake or transparent insurance, then sometimes you want to have all of this money accessible. So how can a wallet provider support that? I think that in the coming years, it will be up to wallet platforms to move quickly to support common transaction standards like ERC20, ERC721, figure out what high-value activities the users will want to perform, and juggle these power users' needs with the business need to onboard new customers where ease of use is priority. So we see this playing a big part of product strategy for all crypto companies. For dApp developers, what I think this means is that it's important to spend time during early development of the application on thinking about your wallet strategy. So, use decentralization only where it's a core necessity and part of the value proposition, and integrate with existing wallets where possible. Keep in mind, the user is going to have very limited space for a different wallet for each type of application they want to use. Today, consumers, they each have maybe only a few bank accounts each. So create experiences where users can use your product but spend the funds primarily from their main wallet and store the bulk of their funds there. The more that community can work towards a set of standards instead of a fragmented application-specific methods and transaction formats, the better the combined user experience is going to be. So in closing, thank you very much for being here. I hope you enjoyed these thoughts about the wallet industry, and I'm going to leave you today with this cryptic-looking graph, which is taken some time back, of the transaction flow between exchanges. So each line is actually proportional to the number of transactions from one entity, like an exchange, to another. And as you can see, there's many, many transactions, but there's also many thick lines. And this represents large entities that are sending back and forth to one another, which is an opportunity for fee savings and scalability on payment channels or side chains. But also, it shows that we are, all sending money or funds and dealing with each other. So it's up to us, the infrastructure providers and members of the community, to gather around these standards, build the ecosystem, connect, support, and foster these network effects on the blockchain. And I think this is how we are going to get blockchain to play a big part in the world economy. So let's work together to do this. Thank you very much.
Thank you very much. So during your presentation, our audience has left us some questions to you.
Great. I think I've left some time for the questions too.
So let me ask some questions. So the first question is, the two-factor authentication still causes confusion, and there is no big change in centralized service process. So I want to know if there is countermeasures.
So in terms of it still causes confusion, I'm going to take that to mean by right now the problem is for phishing, like I was talking about, it just gives you a number, and then the number might be put wrongly into a bad website. And I think there have been an attempt to get many apps where the app gives you also not just a number but detailed information on what you are approving. So that's one of the directions. And then as I talked about on U2f, when you're pressing the button, you're signing for an action, which also includes the domain of which you're signing on. So it prevents phishing. I think that this is one of the things where consumers were actually a lot better off than we were 5 years ago. People are a lot more aware that they need to use 2FA now. And we're also starting to move away from just SMS 2FA. So I'm quite happy and enthusiastic about where it's going to slowly improve over the years. But it takes time because although we have all this new technology, in the end, it's a lot about people. And sometimes people need time to get used to this.
Okay, thank you. And the next question is, to use some private chain and public chain, users have to pay for new account and register it. How are you solving that problem? It could be quite expensive.
Yeah, you're absolutely right. It can be quite expensive, especially when the price is going up of XRP or EOS. So, I mean, in the end, the way that we solve this is we use a technique where actually for XRP, and I'm not sure for US, but I know for XRP, you can set up an account with a key where someone else owns the key. So we can pay for the account creation first, and then we can delegate the key to other signers after that and change that account. And so that's how we have been setting up the account without requiring user to buy XRP first. But I mean, of course, in the end, they have to pay for it one way or the other. And I think that for us is something that we are in communication with a lot of these blockchain foundations and communities to solve. But we are just trying to make a good user experience so that they can get the account quickly.
Okay, thank you very much. And the next question is, I wonder if there is new function that is necessary for exchange transactions, of which calling API is important. And do you have any plan to adopt such opinion?
Can you repeat the first part again? Maybe
Okay.
something has been lost.
Okay. I wonder if there is a new function that is necessary for exchange transactions where the calling API is important.
The calling API?
Yes, API calling.
I mean, I guess I don't really get the question because for the exchange transactions, the calling API is already, I mean, they're all API calls right now. I'm not sure what the question is in this case. We're always looking at our API, of course, and with new types of blockchains, sometimes the APIs change. So between, obviously, Ethereum transaction has a different RPC to EOS transaction or a Bitcoin transaction, but we usually are able to go a level on top of that, and so our APIs actually don't have a different appearance in the end. But I'd be interested to speak with whoever asked the question later.
Yes, there is a little bit confusion about the meaning of the calling APIs, so sorry for that. So thank you very much for giving